Hello again. So today we're going to talk about lines again, but specifically one aspect of a line that we have not talked about yet, and that is called slope. Every line has something called slope. It's a special characteristic that is unique to every line. Earlier I mentioned two characteristics that most lines have, and that's x-intercepts and y-intercepts. So that tells you the location of a line. But there's something else called slope. It tells you something a little different. It tells you the steepness and direction of a line in a single number. So this single number tells you these two things: how steep the line is and in what direction the line is pointing. So imagine there's a number that I tell you, and I say this is the slope of the line, and immediately you have in your mind an image of how steep this line is, and you know which way it's pointing. That's a powerful piece of information. That's a powerful number. So what do I mean by steepness, first of all? Well, some lines are horizontal, so they're not steep at all. Some lines are close to horizontal, so there's a little bit of steepness. Some are about 45 degrees from the ground, so I wouldn't really call it steep or not steep. And then some lines are very steep, and then some lines are vertical, which is the ultimate in steepness, right? And then you have lines that are mirror images of these three, like this, this, and this. These two have the same steepness, but they're going in different directions. These two have the same steepness, different direction, and these two have the same steepness, but different direction. So this number called slope was invented by people who wanted a numerical value that could measure steepness and direction. So what they did was they decided, okay, let's say we have a line and we pick two random points on the line and we draw a right triangle like so, using a vertical line down from this point and a horizontal line over from this point to create that right angle. And this vertical side of this right triangle has been dubbed the rise, and this horizontal side the run. And they decided, well, let's just make a ratio out of this. Let's take this, the length of this side, which is called the rise, and put it over the run. And let's call that slope. Okay, if that's the definition of slope, now let's see what kind of consequences that has. For a line that is not very steep, the triangle is going to look like this. So the rise over the run is going to be a very small number. It's going to be some sort of fraction, right? For a very steep line, the rise over the run is going to be a large number because the run is so much longer. The rise, sorry, is so much longer than the run. So that means the steeper the line, the bigger the slope is. The less steep the line, the smaller the slope is. Which kind of makes sense, because if let's say you're a rock on this mountain and it's very steep, you're going to roll down really fast. If you're a rock on this hill which isn't steep, you're going to roll slow. So you get the feeling that a steep slope should have a larger numerical value than a hill that has a very shallow steepness to it. And then what about horizontal and vertical lines? Well, a horizontal line doesn't have any kind of steepness to it. If I were a rock on the horizontal line, I wouldn't be moving, right? Well, what does that mean about the numerical value of the slope? Well, if I take 2 points, and I try to make the right triangle, well, I can't, right? Because I can't make this right triangle have any height since these 2 points are at exactly the same height. So the rise here is 0. If the rise is 0, and then the run is some number that's the distance between these 2 points, then that means the slope is going to equal 0 here. Which kind of makes sense. If a horizontal line has no steepness to it, you would expect that the slope is 0. Now what does that mean about vertical lines? Well, I pick 2 points on my vertical line. Yes, this is my rise, but now I have no run. I have no run. So I've got the rise over 0. Well, we know we can't divide by 0, so this becomes no slope. No slope. So horizontal lines have 0 slope and vertical lines have no slope. Okay, well, what about the lines that are leaning to the left? I mentioned earlier they have the same steepness, but they have a different direction. I cannot certainly say that these 2 lines have the same slope. If slope is supposed to tell me steepness and direction, they have to be different. But they do have the same steepness. So for all lines that are leaning this way, which I consider leaning to the left, or at least tipping to the left, these all have negative slopes. So let's take this line. Let's pretend that the ratio here is 5 to 2, which gives me a slope of 5 over 2. And let's say this line has the same steepness as this line. It's just pointing in the opposite way. So the rise over the run is also 5 over 2. Well, I can't say the slope is 5 over 2, because that's reserved for this one. So it's negative 5 over 2. Simple solution to that. Okay, so positive slopes go this way, and negative slopes go this way. Now, how do you calculate these rises and runs? I just made up these numbers 5 and 2 to make my point. But what if you didn't know ahead of time what the rise and the run are? Well, you would have to calculate them from the coordinates of 2 points on the line. So I would have to give you these 2 pairs of x comma y. Without that, you can't find the slope. Okay, so let's say we have a line here, and I pick 2 random points on the line. I draw my rise, I draw my run, and I'm going to give these 2 points coordinates called x1, y1 and x2, y2. Now the distance of this point down to this right angle is going to be the y coordinate here minus the y coordinate of this point. Now the y coordinate of this point is going to be the same as the y coordinate of this point, so it's y1. So the distance here is going to be y2 minus y1, y2 minus y1. That's the run. I'm sorry, that's the rise. Now the run is the horizontal part of this triangle. The distance from here to here will be, starting from the y-axis, this, which is x2, minus this, which is x1. for x2 minus x1. That's the run. Okay, rise, y2 minus y1, run, x2 minus x1. That is our slope. Okay, so let's put this into action. Let's say I have 2 points on a line, and they are 1, 4, and 4, 8. Calculate the slope of that line. The slope will be, let me label these first, x1, y1, x2, y2. The slope will be 8 minus 4, that's y2 minus y1, over 4 minus 1, which is x2 minus x1. 4/3. Which means, if I have this line, and I make my right triangle, the rise here is 4. That's incorrectly drawn. Here's my right triangle. Rise is 4, and the run is 3. Let's try a few more, because you're not necessarily going to get a positive slope. Okay, so here we have the slope being negative 4 minus 3 over 0 minus negative 2. Negative 7 over 2 is my slope. That's a negative slope, so it's going to be something like that. And on this line, with these 2 points, 6 or negative 6 minus negative 1 over 2 minus negative 4. Negative 5 over 6. And just so you see that this formula for finding slope also works with horizontal lines and vertical lines. Let's say these are the 2 points you have. y2 minus y1 is 2 minus 2, and x2 minus x1 is negative 5 minus 4. That gives us 0, which means that this line is a horizontal line. And if you think about it, those 2 points lie on a horizontal line. So even before you calculate the slope, probably you would have noticed that. And then in a vertical line situation, the abscissas would be the same for every point. Negative 8 over 0 is undefined, so there is no slope, which is what you would expect if you had 2 points that existed on the same vertical line. Now, do you have to know 2 points from a line to be able to calculate the slope? Not necessarily. You can actually get the slope from the equation of the line. Last time I showed you how to graph a line from the equation. Well, you can also get the slope from the equation without graphing the line, and you don't have to do any calculations. So last time I also told you that this is the general function of a linear function, and I highlighted m and b for a good reason. I'm going to switch from f of x notation to y because we're graphing. Again, m and b are the important points. So I never told you what m was. Now I can tell you. M is the slope. The coefficient of x there is the slope, which is why I said you don't have to calculate anything to find the slope. It's right there staring at you. So in this linear function, the slope equals 2. M equals 2. I'm going to use m from now on for slope because that's what it stands for. So now you already have a picture of what this line looks like before you've even plotted any points. It has a slope of 2, which means the rise over the run is 2 to 1. The ratio is 2 to 1. So it's a pretty steep line. And it's a positive slope, so you know it's going in this direction, not that direction. And what about that other number, the b? That is your y-intercept, which is what you would expect, because how do you find the y-intercept? You plug in a 0 in for x to find the y-intercept. Well, if you plug in a 0 there, that knocks out the 2x, leaving the 3. And it doesn't matter what that coefficient is. Anytime you put a 0 in for x, it's going to knock out that entire term. Which means this is always the y-intercept. You don't have to do any calculations to find that either. So just from the equation of the line, you get a lot of information. You get the slope, which tells you steepness and direction. You have the y-intercept, which automatically gets you 1 point. Which leads me to this. A second way to graph a line. Let's use y equals 2x plus 3. So the first way I told you to graph a line is you pick points, preferably the x and y intercepts, to find, and you plug them in. When you plug in 0 for x, get the y. You plug in 0 for y, get the x. And you'll have your x and y intercept, and plot those 2 points. Well, there's another way to do it too. And it does not involve any kind of table. It involves m and b, the slope and the y-intercept. First of all, the y-intercept is a point, and we already know it. It's 0, 3. So I can plot that point without doing any sort of calculation. Now I need a second point, because we always need 2 points to graph a line. But I'm not going to go to the table to get my second point. I'm going to use my slope. I know that 2 means that the slope is 2 over 1, which means the rise is 2 and the run is 1. That means from this point, I can find another point on the line by going up 2, 1, 2, and to the right, 1, 1. There's my second point. And then I can draw my line. So again, I go up 2 because that says the rise is 2, and I move to the right 1 because the run says 1. 2 to 1 is my rise over run, and then I just count to find the coordinates of my second point. The y-intercept was 0, 3, so if I went up 2 and over 1, that would have put me at 1, 5. And my line is graphed. Okay, that's it for this video. And in the next video, we'll talk more about this form of a line and a couple of other forms of a line, and practice more graphing, and maybe even talk about how to get the equation of a line from 2 points.